Hi, my name is Stuart Wallace and I'm a lead consultant with OpenCredo. In this video, we're going to look at reducing our downtime during our Terraform applies. We're going to be using the UpCloud platform, but everything we learn in this video should be applicable to any resource on any platform. We're not going to quite get down to zero downtime in this video. We'll get pretty close, but if you're interested in shaving off those last few seconds, please leave a comment down below and we'll try and make a video about that soon. So for the purposes of this video, we've put together a really simple demo application that simply just returns hello. So if we flip to the browser, we can take a look at that. We can see that we're just returning a hello, and we're returning back a version number as well that we can kind of modify as we go through a few iterations of this application. Hit refresh, it's just saying hello to us. If we flip to the terminal, we're going to have a quick look at the application code. It's very simple. It's a little Go application. It's just returning hello to any HTTP request that we get. And then obviously we can modify this version number as we go through. We are using GitHub, so GitHub Actions to deploy this. We're also using Terraform Cloud. And we're also using Packer to build an image with our application as well. I won't go into too much detail about those tools in this video. If you're interested in having a more in-depth look at those things, just leave a comment below and we can make a video about that. I'll just quickly show you the Terraform code here as well. So we are simply deploying an UpCloud server. So we're using the UpCloud platform for this. So we're just creating ourselves a server in the London region. We're using this template ID. So we're creating a custom image using Packer, and we'll be using that for this. And we're obviously creating a public network interface. So we'll have a public IP for this deployment as well. So I think first things first, we should see where we are. So we'll make a change, we'll deploy it, and we'll just have a look at what our downtime is like for that. So we'll just simply go into our Go code. We'll just bump up the version to 1.1. We will add it to Git. We will commit that. And we'll push it like so. And if we then flip over to our browser, like so, we should see that we've got a new application that's building our new version, which is this one here. So we're going to build an image. We are going to build the application, build an image using Packer, and then we will apply the Terraform. And we'll fast forward at this point and we'll have a look at the Terraform output as it's running. So that's it, having finished building our Packer, which now it's going through our Terraform deployment. So we're doing a Terraform plan to begin with. So Terraform plan will just go and examine the current infrastructure state, what we want it to look like, and figure out the differences. In this case here, because we've created a new storage device from a new custom image, it's decided it needs to replace our server for us with a new server with that image. And so now we're applying that Terraform. And if we flip back to our terminal, we can keep an eye on that uptime, downtime monitor just there, and it will tell us how things are going. So it's now gone down. So now we're now experiencing some downtime. So we'll see how long this takes, and then we'll have a look back at the Terraform logs and find out what it was doing during this downtime. There we go. So we can see that it's now back up again, and we had about 50 seconds of downtime. So there was something going on for those 50 seconds, which meant that obviously we weren't able to service any traffic. So if we flip back to the browser again, and we can have a look at those Terraform logs and find out what was going on in that period. So we can see here, obviously, it's output what it's going to change. We're using floating IP addresses, which I'm not going to talk about in this video, and obviously it's making some changes to those. but also we can see here it's replacing our server. And the reason it's replacing our server is, as I said earlier, we've built a new custom image and we've got a new storage device based on that image. And so it wants to replace the whole server for that, which is what we're expecting it to do. And if we look down here, cloudserver.app, this is our application server, and it's starting to destroy it. So it's destroying the server first, and that takes about 10 or 15 seconds, and that's obviously, a part of our downtime. And then it's creating a new server, and again, that's taking a period of time for it to come back up again. So that's the bulk of our 50 seconds of downtime, and so. I guess the question is there a way that we can control this? I guess actually, what we really want to happen in this scenario is that we create the new server first and then destroy the old server. Well, yeah, we can fix that. So if we flip over to the terminal again, and we go and look at our Terraform, it's actually pretty simple. To flip that around. So Terraform has what's it's called life cycle configuration, and so we can go and change that, and we can set that life cycle to create before destroy. That's it, and if we deploy that, we should hopefully reduce our downtime. Whilst we're at it, we will bump up our Go version number again so that we can see it's changed, because obviously we can see in our little monitor that our version bumped up after that downtime. So we change it to 1.2 as well. We can add both of those changes. We can commit those, and we can push those up to GitHub. And if we then flip back over to GitHub, we can see that we've got a new version now building. And we'll go in here and have a look. So it's currently building the new version of the application, the Go binary itself. It just takes a few seconds. It will then build the Packer image for us, and then it will go and apply the Terraform. So we'll fast forward over this bit, and then we'll regroup when the Terraform is being applied. So that's it, finished building the image. It's now started to apply the Terraform. So we're obviously doing the plan again to find out what's changed. Again, we're expecting the main change to be a new server will be deployed because we've built a new image with a new version of the application. Yeah, and that's what the plan is telling us. Then if we look at the apply, so it's beginning that apply, we'll get the output of the plan again. Yeah, so that's what it's going to do. So if we flip back to the terminal again, just to kind of keep an eye on that downtime. There you go. So that's it done its deployment. So I think we're about 50 seconds before. Our downtime's now 57 seconds. So we've got our downtime to about 7 seconds in this case. And I think in my trials, the downtime is somewhere between 4 and 8 seconds. So as you look at these Terraform logs, we can see that it wants to replace our server. And that's because we've got a new custom image, and so it wants to replace it so we can use that new custom image. Obviously, we've flipped around using the lifecycle configuration. We flipped around the creation and the destruction of that server. So you can see here it's creating that new server first. So it took 23 seconds to do that. And then obviously we've got a bunch of other Terraform going on here, such as managing a floating IP address. So that's, and down here we can see right at the end we're destroying that server. And And so obviously that's taken out the bulk of our downtime. So taking us down from 50-ish seconds down to 7 seconds. And in this current architecture, it's a fairly naive architecture. It's about as fast as we can get it. We've got a floating IP address involved, and that takes a few seconds to move from one server to the next. But we still have one problem at this point. What if there's a problem? So what if our new application is unresponsive, or maybe it's returns errors for a period of time before it comes up? Is there anything that we can do about that? So to simulate our application having an error just after it's first deployed, we will change our code just to bump the version up. So if we look at this, obviously we bumped up the version number. We're grabbing the time this starts. If that time is less than 2 minutes, the time since that time started is less than 2 minutes, we'll return a 500. We'll return an error message, and then we'll obviously leave this function at this point. Otherwise, we'll carry on down here and we'll just say hello as we've been doing all along. But we've obviously bumped up the version number, so that'll be in our response as well. So we just add all of that. We commit that, and then we push that up to GitHub. And then if we flip over to GitHub, we can see that that's now building. And we head over here. So it's building as it's been doing before. So we'll fast forward until we get to the Terraform apply again, and then we'll look and see what's happened. Starting the apply. There you go. Right, so it's begun the apply. So if we flip back to the terminal, we can keep an eye on our downtime again. Actually, let's just quickly, we'll go over here. We will do that just to reset our timers. It saves me having to do some maths. It's finished doing that. So obviously now it's down. It's flipping over the IP address. IP address is now flipped over, but it's still down. And obviously we've put that 2 minute downtime in there. So let's just obviously let this play out. We'll fast forward a little bit, and we'll see it come back up again. And then we'll think about maybe how we can fix this. And there we go. We can see it's come back up again. So that was down for about 2 minutes. That's what we expected. So how can we fix this, or at least how can we be certain that our new application is ready for traffic before we flip over to the new version? So we can actually achieve this in Terraform. So we've obviously got this lifecycle which changed the order, and so Terraform supports provisioners. So these are little blocks that allow us to do something to the resource that we've just provisioned. So there are a variety of these. Some of them include sort of Puppet, Chef, and Ansible. So if you've already got existing, Chef recipes, Puppet scripts, whatever you've already got, Ansible playbooks, then you can go and run those against a server you've just deployed. In reality, you should wonder if that's the right thing to do. Maybe using a tool like Packer to build a custom image is the right thing to do. But there are other uses for them as well. So there is one of them is called local exec, one of the provisioners, and that allows you to run some code. So whether it's a bash script or a compiled binary, it allows you to run that on the machine that's doing the Terraform deploy. So in our case, we're using Terraform Cloud, so it's running on one of HashiCore's machines, and we can do something in there. So there's a little bit of code. I'm gonna copy and paste it in. You don't want to watch me type badly again, and we'll put that in here, and then we'll have a quick look about at what this is doing. So this is a local exec provisioner. It's a little bash script, and what we're doing is we are keeping we're looping around, and we're using curl to poke our application. So we're using self.network interface .ip address. So that's basically that is referencing this network interface here. So we're getting our own IP address. So again, this is the IP address of this server, not the floating IP address, because that's still pointing to the old version. And we're just getting the response code. If the response code is 200, okay, then we will say that the application is available. We will exit this provisioner with a 0 error code, and we will carry on with the provisioning. If it's not 200, and again, obviously you can change this response code to be something that's valid for your application. Just in this case, 200 is a valid response in our application. If that fails, then we'll keep a fail count, and we will loop around here until fail count is greater than 30. Then we will say the application is still unavailable. We'll exit with a non-zero error code, which tells the provisioner, tells Terraform that the provisioning step went wrong, and it will just stop at this point. And it'll be a kind of a failed Terraform deploy, and the old application, the old version application will still be there handling traffic. The server will be left sort of lying about, but when we correct it, run the Terraform again, it'll all get tidied up. We're doing this 30 times, we're sleeping for 10 seconds. So essentially, we're giving ourselves 5 minutes for the new version of the application to kind of say, I'm ready for traffic. And that's it. So if we come out of here, and if we just do a quick Terraform validate, no, go to the Terraform directory first, do a Terraform validate on here, and tells us it's valid. I've at least got the right number of curly brackets, and we can go into our Go application, and we will bump up our version so that we can see it change from 1.3. And we'll add all of that. We will commit it, and we will push that up to GitHub again. And we will hopefully see, yeah, if we flip over to the browser, we can see that we've got a new version that's in the process of deploying. And if I go into here, and yeah, so it's building. So we'll fast forward until we get to the Terraform apply, and then we can see what's happening at that point. So yeah, you can see it wants to make the changes we're expecting it to make. So it's changing our server. Yeah, so it's now creating the new server, and if we flip back here, we can see. Oh, I should probably just quickly flip this over. So it's still our old version is still up and responding, and it's still creating the server. So actually now, if I flip back here to the browser, you can see here that actually now it's looking at our local exec provisioner. We got a zero back. That's actually curl giving us an error, and we're now sleeping for our 10 seconds. We're now getting a 500 back. That's what we're expecting, and we should see those 500s come back, for the next couple of minutes. And then if we flip back to the terminal, we can see that again our old version of the application is still responding and still saying hello to us. So we'll flip back to the browser. We'll fast forward a little bit here. So we're nearly there. So we'll flip over to the terminal. So we saw it went down for the 5 seconds we were expecting, and we've got a new version 1.4. But obviously we weren't down for those 2 minutes, so it did what we were expecting it to do. That's great. So that's all I have for this video. We've covered using Terraform's lifecycle configuration to change the order in which our resources are created and destroyed, meaning that our new resource is created before the old one is destroyed, reducing our downtime. We've also looked at using a local exec provisioner to check that our resource is ready for traffic before we then go on and destroy the old one. In this video, I've used GitHub Actions, I've used Packer, Terraform Cloud, and UpCloud's floating IPs. I've not gone into any of those in any depth. If that's of interest to you and you'd like us to cover those in future videos, just leave a comment down below. Again, if you've got any questions, please leave a comment down below. There'll be a link below to the GitHub repo for all of this, so you can see what I've done and how I've put it together. And thank you for watching. Goodbye.